Okay, well, we are here about 2 minutes. So we'll go ahead and start. Hello and welcome everyone to 101 Uses for a Dead Well webinar hosted by Carbon Expo. My name is Leslie Self and I am a director for Carbon Expo. Those of you new here, Carbon Expo is a one-day virtual event aimed to unite oil and gas industry leaders with solutions to achieve their energy transition goals. We had a successful event last March, and we are excited to share plans for 2023 today at the end of our webinar. You're all here today to learn about what we can do with your dead, idle, or inactive wells. You'll be hearing from a broad range of innovative solutions from our speakers. These presentations will last about 15 minutes each, and then will be followed up by a Q&A session at the end. At any time during the webinar, feel free to go ahead and submit your questions using the Q&A feature at the bottom, and also use the chat box to share comments with the entire group as we go. Lastly, today's recording will be sent via email next week. So to kick off the webinar, I would like to go ahead and poll the audience. I have a question here for everybody. Let me go ahead and get that launched. So the question is, how many idle or inactive or dead wells do you have on your books right now? I'll give you about 20 to 30 seconds to go ahead and answer that. So far, we have about half of the attendees have answered our poll. So the rest of you folks, go ahead and throw your answers up. No wrong answers here. Okay. So I can go ahead and share those results. Okay. Well, there's the results for you guys. You can see a few of you, you're not alone in having these inactive wells on your portfolio. And those of you who don't have any yet, I'm glad that you're here being very proactive to make sure that you have solutions at the ready whenever those do come up. So now I'd like to go ahead and introduce our moderator for today's event, Stacey Taruscio. Like many of our panelists, Stacey has a long background in oil and gas and has transitioned her knowledge to develop projects in the voluntary carbon markets. Stacey is a dynamic leader in the sector of oil and gas. You may know her from her work as the founder and CEO of upstream E&P Renewell Energy, her work creating carbon market opportunities as founder and CEO of Renewell Energy Solutions, and co-founder of the nonprofit Fellow Environmental Partners. She's an engineer by trade and an entrepreneur in spirit. She is intent on leveraging the expertise of the oil and gas sector alongside the humanity of the industry's community with a focus on research, education, and reclamation of orphaned and abandoned wells. So go ahead, Stacey.
Thank you. I don't see myself on the screen, and that's probably quite all right with me. Oh, there it is. Hi, everyone. So we have a really great lineup of panelists today. Each of these folks has their own innovative solution to the legacy oil and gas well cleanup that we're all facing today, to put things into perspective. And I know a lot of you guys know this, but there are millions of non-producing wells in existence today, and the pipeline is full of marginal and producing wells that we need to be prepared for. So not all of these wells have future utility, and plugging some of them will be critical, but any solution that converts a liability into an asset is valuable. And some of these folks will give us their take on what that future utility could be. So as we each consider an individual role in this energy transition, it's really very important to me and to everyone at Fellow to say that to accomplish change, we need to enlist the skills of both the environmental and the social justice warriors that we have out there working alongside the brilliant people that make up our energy industry. Many of them are here today. So with that in mind, I will introduce our first panelist, Kemp Gregory of Renewell. Kemp spent about 5 years working for Shell as a petroleum engineer, where he installed cutting-edge downhole technology. He managed capital intensive projects, coordinated large operations across North and South America. And in 2022, he co-founded Renewell. He leads the team's efforts now to clean up and convert 1 million idle wells into hundreds of gigawatt hours of clean energy storage. So he is our first example of oil and gas engineering and tech truly transitioning to net zero type opportunities. So very quickly, Renewell's forthcoming prototype is intended to show that they can charge their energy storage devices within the wellbore in these oil and gas wells by lifting a cylindrical weight to the top of an oil well. He'll go into this in much more detail, but there's a regenerative winch that lowers the weight to the bottom. And it really allows us, from my perspective, gives us the ability to provide much needed solutions to some of the intermittent energy supply problems that we have out there today, because this becomes a switch that you can turn on and off. So Kemp, I'll let you go ahead.
Thanks very much, Stacey. That was great. Okay, I'm going to share my screen and walk through some slides. And here we go. Just a little audio and visual check. Everything's okay. Cool. All right, so our mission is to clean up and convert 1 million idle wells into 1 million hours of clean energy storage. So we're after a lot of idle wells. We're very much a volume play. We're trying to be as suitable as we can and as many wells as we possibly can. So this isn't going to be my typical presentation because I assume this crowd is very, very well informed given the title of this presentation, title of the expo. So I'm gonna kind of cut to the chase. And only after just a little bit of background on the company. So founded in 2019, originally it was just called Gravity Well, 2 founders and a laptop. And we spent 2021 building the prototype, which was done in the middle of nowhere, East Texas. And then we put that prototype in the field on a well in the Barnett. So we converted a well just outside of Dallas. And sort of to make all that happen, we had some money from Stanford. We raised from some angels and friends and family, and to date, we're in a seed round and received some non-dilutive funding from the Department of Energy. But okay, what do we do? So Stacey mentioned there's a regenerative winch involved, and that's the truth. We're very akin to pumped hydro in its broadest applications, and by that I mean, you know, they're moving water up and down a hill using a turbine. So their mass is water, and their conversion device is the turbine. Our mass is steel. Big, long steel tube filled with mass additive, and our conversion device is a regenerative winch. So when the weight's at the top of the well, it's got the maximum potential energy possible, and then as we let it descend, it pushes that power back to the grid by spinning the regenerative winch in its generator mode. So it's designed to be a motor generator. So just a quick recap there: weight moving down is power out, and weight moving up is power in. This only happens after the pump jack has been removed, the tubing has been removed, and that first cement plug has been set, isolating the reservoir. So if P&A, plug and abandonment, is a 10-step process, we basically talk to the oil and gas company. We say, look, do steps 1, 2, and 3. Remove the pump jack, remove the tubing, set that first plug, and now we'll pressure test the casing, make sure that the casing's not just Swiss cheese. And then, if all's good, then we convert into a gravity well. And we get to essentially pause steps 4 through 10 of the plug and abandonment process, which I'll get into that in more detail. But this is the gist of it. Some common questions we get are, you know, is the wellbore empty? No, the wellbore is full of fluid. So one of the first things that we do after we set that plug is we have the workover rig flush out the well. So no more hydrocarbons in there, or at least as much as we can get out. And then we just leave fresh water, something akin to packer fluid surrounding the weight. A lot of the next question we get often is, what is the weight? The weight is just oil-filled tubing, recycled oil-filled tubing. It doesn't even have to hold pressure, so we could use used or even compromised tubing, as long as it didn't have any holes or, you know, any concerns about yielding. So we just make up the joints using the drill, using the workover rig, and then we fill them as we go. Next common question is, well, how long is the weight? The length of the weight is a function of the depth of the well. So it's typically somewhere between a half and a third, and that has a drastic impact on how much energy we can store in the well, which is sort of the next common question is how much energy can you store in a well? And that has everything to do with the casing size and the depth. Really, it just comes down to a volume play of how much mass can we get into the well? Because at the end of the day, our potential energy really is just mass times gravity times height, or good old high school physics, MGH. Okay, so what have we been up to? So you already saw a brief video of, well, it's more like a GIF of the Texas pilot well, but here's a little bit longer video. So there, I'm going to pause this just quickly. Happens kind of fast, but that winch is moving in the counterclockwise direction. So you're looking sort of straight down the system here, and that's the wellhead in the distance between the boom arms. So we are discharging, we're pushing power to the Texas grid in this video. So there's me walking along. There's our sort of little cheeky tagline, oil wells that end well. We often get asked why the second powertrain. That was just there for testing purposes originally. This is the prototype that we have very nerdily named Artemis Prime, or just RD for short. So RD is the one gravity well that we've made, and we have since picked it up and moved it to California. So I'm calling in from Bakersfield, California right now. If my audio and visual is not great, it's because I'm still out in the field. So I apologize for that. I drove in to hijack the pilot gas station's Wi-Fi because I was just out at this site. So that's sort of what we've done to date in terms of field testing. The Texas pilot well lasted about 2 months. We're going to be in the California pilot well for longer. We started in Q3. We'll probably finish up in Q1 or even Q2 of next year, basically trying to scoop up as much empirical data as we possibly can. Okay. I want to talk to you about the perfect well, because I imagine that's sort of what people want to know about. And I've already sort of discussed some of the criteria, but I'm going to give you some ranges because there's a lot of flexibility in our design choices. So we're not beholden to any one design per well. That would be crazy. But nor are we going to like customize for every single well. That would also be crazy. So we're going to sort of slice up the wellbore population into product tiers, and that will probably shake out to be about 3 different product tiers. So that's why I put this massive range on here, is because we can design a lot of different systems. So 2,000 to 20,000 feet. Now we certainly want to start on the smaller side. We're not eager to pick up something that's going to weigh 300,000 pounds in a 20,000 foot well. That would be an engineering challenge that we don't want to get to quite yet. But the casing size is also a wide range, because you can imagine the deeper, let's say you had an 8,000 foot well with 4.5 inch casing. Now that could be doable, whereas a 3,000 foot well with 4.5 inch casing would not be doable, but a 7-inch well with 3,000 feet could be. So it's kind of this, you know, it depends on those 2 factors and how they mix up. We know that the average, you know, typical well in the Permian is probably something more like 5.5. The 2 wells that we converted, one in Texas, one in California, are both 5.5, 17 pounds, strangely enough. So they're sort of almost the same wellbore architecture. And that was actually just a coincidence. We didn't really plan it that way. But we know that that'll probably be the sweet spot, 5.5 inch casing. We need the presence of electrical infrastructure. So if the well is strictly gas well operating off plunger lift, and there's no electrical infrastructure right up to the wellhead, then that's an issue, right? Turns out poles and wires are crazy expensive. I had no idea that it costs a lot of money to build poles and wires. Thankfully, for all the wells that operate off pump jacks or even better, ESPs, you know, we're talking about a lot of electrical infrastructure right up to the wellhead. And pump jacks, you know, range in the, let's call it the 20 kilowatt range, and ESPs are more like a couple 100 kilowatts, which is great because that means that's an indicator of what we can push and pull with our system. In the event that we have to upgrade a system, like let's say the pump jack was only, you know, 20 kilowatts and we want to push it to 60 kilowatts because the well can handle it, we've costed that out. It doesn't break the bank. It's just a reasonable cost to upgrade the power that we can push and pull at a site. So the next is inclination and dogleg severity. We sort of attack this in 2 ways, as much empirical data as we can get, which is basically the California well. The Texas well we picked was perfectly, it was 0s and 1s, which we did on purpose because we wanted to sort of start easy. But the California well's got some dogleg severity and some inclination. So we will be able to report back on that with much more precision over the next 2 to 3 months. as we just operate the well up and down all day, every day. But we've set some general parameters. We try to be conservative. So those factor into our market size, which I'll talk about in just a second. Next up is casing integrity. We like to assess this in as low cost a way as possible because it can get pretty expensive as soon as you get downhole. And that is just a pressure test. We're sort of presuming that if the well can handle a pressure test, then the casing is not in terrible condition. For the California pilot well, what we did was we ran a multi-finger tool and a device to detect the thickness of the casing so that we can do a before and after, so that when oil and gas companies ask us like, hey, how much are you damaging the casing, we can say, hey, on this pilot we damaged it 0.001 centimeter or something like that. So that's sort of how we think about casing damage. Also, the weight is not moving terribly fast and it's surrounded by water, so don't picture anything sort of flying up and down the well. It'll typically take about an hour or two to get down and an hour or two to get back up. Weight speeds move at about 3 feet per second. Next is perf depth. There are wells out there who've, maybe it was an 8,000 foot well, but they perfed it at 5, right? So that means it's a 5,000 foot well to us. So we account for the likelihood that the well depth has been decreased based off of how often they perf really, really far up the casing. It's really in their best interest to not do that, right? They want to drill a well to a certain location and then perf it at that depth. It's only when they're interested in, stimulating other zones uphole, which is, I dare say, not the majority of wells. So we don't think that perf depth is going to be a major source of loss of vertical depth to repurpose. Next up is sort of the energy storage side. So what Renewell does, in our site selection, which I'll talk a little bit more about later, is really we mash these two worlds together, right? It's all this wellbore criteria stuff, and then it's all this energy storage stuff. So it's great to have electrical infrastructure up to the wellhead, but if it's not connected to the big grid, then that's a problem. We could always operate as a microgrid, but we'd much rather have connection back to the main grid. So it needs to be connected to the grid, and then there needs to be a need for energy storage. Right, so it needs to be either embedded within an actual field, or more broadly, like have a decent share of renewables in the market. Texas and California being great examples of, pushing somewhere between 20 and 30% of their energy coming from wind and solar, respectively. Last but not least, we'd like it to be near a volatile node. So if all of these factors come together to decide whether or not this is a suitable well, the volatility of the node has an impact on the amount of energy storage revenue we can make at that well. So we'd like it to be more volatile. That's sort of what helps energy storage make money in the arbitrage market. Okay, I was talking about the science of site selection a second ago, and this is what we've called our efforts in that arena to date, namely SWIFT, or the Suitable Well Finder tool, which is sort of a cheesy name. Honestly, I started with the acronym and I worked backwards. But the idea here is that you compile all the best data. So I'm talking about drilling info. I'm talking about any differentiation between drilling info and IHS or whomever else. And then also proprietary data from the oil and gas companies. So we've signed a handful of MNDAs so that we can get oil and gas companies information that they don't post through the state regulator and have to sort of get it directly from the source, so that we can have what we're hoping it becomes the world's best database on idle wells. And in that way, hopefully be able to quarterback future solutions that make use of the same infrastructure. And then last but not least, identify the most lucrative candidates and then secure exclusive agreements with them. It's sort of us trying to close the proverbial door behind us, so that if we could get, Chevron to say, yeah, here's all of our data. Okay, screen us for the best wells. Okay, we tell them the best wells. Then we say, great, Chevron, we'd like to be your provider for gravity-based energy storage. Hopefully they say yes, and then we're off to the races. Okay, I discussed the large market, and I've been hitting on the idea like not every well is suitable, but all those factors essentially boil down to what we think is about a 30% suitability rate. So there's that 2.6 million idle wells in the United States and Canada. And when we go from our TAM to our SAM, what we're doing is we're basically applying that 30%, all of those different factors all mashed up together to come out to, we think, about every third well. Now I'm talking about this like stock, and most of you know better than probably most other people in the world, but it's not really a stock, right? It's a flow. There are another 700,000 wells in the US that are stripper wells. So they're sort of knocking on the door of becoming inactive. And so that's good news for us, right? We want more idle wells so that we can repurpose them. We want to catch them before they become orphans. The ratio of idle wells to orphan wells is a lot to a little. So the more idle wells that we can repurpose, the more orphan wells you are preventing. Going from SAM to SOM is not as technical. It's way more hand wavy. It just assumes that we're one of four in the long run and that there are three other competitors doing exactly what we're doing. Now, the ARR is annual recurring revenue, and it comes from two sources, right? There's the energy storage market, which is a variety of services and or arbitrage. And then there's a market that doesn't exist yet. And I imagine it's going to be a common discussion of this chat, which is kind of cool because it's the first time we'll be able to talk about it with others. And that is deferment. We are basically selling deferment. We're trying to create a market for deferment. As it is, that market does not exist, right? Because an idle well that gets converted into a gravity well is no different in the regulator size just because it's got a regenerative winch on top, right? It needs to be recognized as a new thing. And so to that end, we've spent a lot of time talking to California Geologic Energy Management Division, or CalGEM. And we really like them. They really like us. They basically said, go do a pilot. So that's what we did. And that's what we're doing. So the idea is we're going to start in California to create this market where we can effectively sell deferment once an idle well has been converted into a gravity well. So we're not selling deferment for free. We take what we call an activation fee. And that activation fee is commensurate with the amount of money that we're going to save the oil and gas company from the alternative of a full P&A. So it's sort of like, pardon the grim analogy, but it works. We're sort of plucking wells off of death row as they were up for plug and abandonment and saying, look, there's this whole new option that you didn't know about. And it's going to cost less than a full P&A. You're going to get to save money. You're going to get a cut of the energy storage revenue stream. And we're going to charge you an activation fee for this service. Okay, so future outlook, like why do we think this is going to work on a big scale, and sort of continuing to honor the fact that we're sort of in two worlds. There are grids out there, specifically CAISO and ERCOT, and this trend will continue, sort of the trend of renewables being cheaper than fossil fuels in terms of new installations. But, there's an intrinsic truth also in here that civilization's demand curve does not match Mother Nature's supply curve. And so what we're getting is a monumental amount of energy being thrown away in CAISO and ERCOT, markets that have high renewable market share. And so they care a lot, right? That's about as directive a way to throw money away as you possibly can. So that's sort of the energy storage world. And then the oil and gas side is these companies are carrying what the accountants have created as a euphemism for cleanup liability, which they call asset retirement obligation. So all these companies carry an enormous amount of asset retirement obligation, and they don't really know what to do about that. Honestly, they've been building it for a long, long time by saying that they were going to plug and abandon wells in the future, which the regulator has been the regulator, by that I mean like the federal and state governments have been more than willing to play along with. But until now, sort of changing tides are that regulators are getting tougher on oil and gas companies and making them plug and abandon more and more wells, like Colorado, New Mexico, California. These are all good examples of fairly large producing states getting tougher and tougher on plug and abandonment requirements. And that's good news for us. That means the pain point is high, which means we can go in and provide a solution to that pain point. Interesting to note that ERA and California Resource Corporation, they top the list in terms of ARO, and they operate strictly in California, which is just kind of a fascinating little factoid.
Yep, it sounds like we've got some folks on the chat hoping you stay in Texas.
Texas is home. I am a native Texan. I hope to get back. So for me, it's not an if, it's a win, but we got to start elsewhere.
Good. I don't know how many more slides you have, but we're kind of over that 15-minute mark. So do you mind? I know, sorry, I hate to rush you along, but if you can kind of pull it towards the end, that'd be great.
Yeah, I don't even really need to hit this slide because I just talked about the two revenue streams. Deferment works. You guys probably get this. I already described it. Sort of steps 1, 2, and 3 happen, and then steps 4 through 10 get pushed. And we use a workover rig to make all that happen. Energy storage service happens using sort of two middlemen, energy storage optimization, energy storage bidders. We can talk about that in questions, but that's how I see the energy storage market melting together. And this is just a little bit more details on our policy goals inside California. That's it. Thank you, Stacy.
Yeah, thank you very much. And I know we had a question from JC Kester as well. JC, I'll save that till the very end if you don't mind, but I'll make sure it gets directed to Kemp specifically. So thank you for that. And again, in the interest of time, I'm going to move on because we're trying to squeeze so much into this, this time slot here. I'll introduce our next panelist. Her name is Dr. Alicia Dengus. She's with Cemvita. And Cemvita, I even practiced that ahead of time. Doggone it, guys. Alicia, she has a PhD in biochemistry and synthetic biology experience. I don't even know what that means, from Rice University. She spent 6 years doing petroleum microbiology research at an oilfield services company and worked in external technology partnerships for the last 2 years. She recently joined Cemvita Factory in 2022 as a business development manager for the Gold Hydrogen Project. She is our second example today of science coming from oil and gas and being applied toward energy transition. Cemvita is a really cool company. Their sort of headline here is, can we turn subsurface reservoir into a natural underground refinery? What if this refinery could use CO2 as a carbon feedstock? That's the vision for Cemvita's energy subsurface carbon utilization platform. By leveraging this existing legacy knowledge and infrastructure for CO2 sequestration and enhanced oil, EOR, all those different things, can we offer an innovative solution for production of carbon negative and renewable oil? So simply put, because I need simple, what portion of all of those above ground processes can be kept out of the atmosphere by happening at subsurface? Alicia, I'll let you take it from there, and I will pop back on after 15 or so minutes and try to not be terribly pushy, but keep things moving, because that's what I'm here for today.
Great. Yes, thank you, Stacy, very much. Let me just put this into presenter mode real quick. Everything looks okay on your end?
Looks good.
Okay, great. Awesome. Thank you for the introduction, and thank you very much to Dwayne and the Carbon Expo team for inviting Cemvita to be part of this talk. I've been really excited to be able to present what we're working on here at Cemvita. I'm kind of glad you mentioned I have no idea what synthetic biology means, because I'm sure there's a lot in the audience that if they've heard of synthetic biology or microbiology, they're probably used to associating microbiology and oil and gas, you know, kind of as the bad bugs, and we don't want them because they cause things like corrosion and reservoir souring and things that we don't want in our oil and gas assets. But hopefully today, and just a quick 15 minutes, I can convince you otherwise, that there also is such thing as good bacteria that can do really, really useful things for not only us in subsurface biomanufacturing, but some of the other verticals within Cemvita as well. So because we're kind of a little bit different, I want to just spend a quick minute or two to explain a little bit more about Cemvita and what we're trying to do as part of the energy transition. And then I'll go a little bit deeper dive into gold hydrogen and how that would relate to idle wells and a technology that can be used for those. So overall, Cemvita was started in 2017 with the goal of being able to find a way to reverse, use synthetic biology to reverse climate change and decarbonize some of the heavy industries as we all are moving towards this energy transition. So we really are looking at using kind of nature-inspired solutions that would be able to empower the energy transition and create a brighter future for those coming after us. So using biotechnology solutions for what we say is sustainable extraction of resources, bioproduction of chemicals and fuels, and renewal of waste streams into value. And we do so currently operating under 3 different business verticals. The CO2-based biomanufacturing and the subsurface biomanufacturing teams are headquartered in Houston, Texas, and our biomining vertical is located up in Denver, Colorado. And the CO2-based biomanufacturing is really kind of the project that put Cemvita on the map. Was a partnership with Oxy, where we looked to take their CO2 and use that as a feedstock for our Cemvita synthetic biology microbes and convert that into bioethylene. So using kind of that same project mindset, we are able to look at different synthetic biology pathways to figure out how to use CO2 as a feedstock for various other products as well. So another big one that put us on the map was a partnership with Oxy and United to use CO2 in our microbes to produce sustainable aviation fuel. And there was a press release that went out about that a little while ago. And then our biomining team up in Denver, they are using Cemvita microbes to extract rare earth metals. A couple of projects they're working on being lithium bioextraction, as well as copper bioleaching. Happy to put anyone in contact with them if they want more information, because that's about the extent of my mining knowledge. But what we're really here to talk about today, and what I'll focus more on now, which I know is what we're interested in, is how do we use the reservoir as a bioreactor for subsurface biomanufacturing. And our flagship project in this vertical is the gold hydrogen technology that I'll talk more about here. And one last company slide before I dive into gold hydrogen. I would be remiss to not mention and give credit to the executive leadership team that's really been trailblazing all of these projects at Cemvita, and call out, mention that the 75 team members strong we are that are really driving this forward. Obviously, I won't go into details on introductions, but hopefully you can see by the different logos on the screen, we've got quite a bit of industry experience on our team that's really made a big difference in taking a lot of these really great innovative ideas and driving them towards true, commercial application in areas that need it. So now what we've all been waiting for, why are we interested in gold hydrogen, and what is it? And really kind of, when I wake up every morning and I'm thinking, why am I coming to work each day? What is my driver? Everyone's kind of focused on this 2050 world, and what are we going to do? And how are we going to be able to, keep the environment in a way that's sustainable for the future? And so there's really two kind of major things that keep gold hydrogen kind of driving forward. And one of those is being this increased pressure to keep fossil fuels in the ground. And the other is kind of the increased demand for hydrogen, and especially clean hydrogen. So the two of those really set gold hydrogen up nicely as a technology that we're trying to drive forward. And I know before we get caught up in the colors, there's a lot of colors of hydrogen out there. What we mean when we say gold hydrogen is kind of a self-defined term that it is produced biologically, so by microorganisms and within this reservoir subsurface. So using our own proprietary microbes and nutrient package, we would inject that technology downhole into the reservoir, and then the residual oil in place would then be fermented by the microbes, and then they would be producing hydrogen, CO2, a few other byproducts that we would produce, and then process the different byproducts and be able to use the hydrogen for either hydrogen itself, convert it to power, turn it into chemicals such as ammonia. And in our initial kind of planning, we're looking at taking the CO2, re-injecting it into a different pocket of the reservoir, so that way we can maintain, a lower carbon intensity of the process. I should mention, since we're on this call of what to do with 101, uses for idle wells. So we are targeting kind of end of life depleted assets that have been through sort of secondary and tertiary recovery already, but there's still enough residual oil in place that we could use that and turn it into hydrogen. So really a way to bring another way to bring oil and gas into the energy transition in a different way than the Kemp had just mentioned. And so I know we could have a whole hour-long lesson on the different colors of hydrogen, and we don't have that kind of time. But what I really want to get at is, the main thing that we're looking at in the industry is shifting away from the colors of hydrogen and really focusing on the carbon intensity of hydrogen production. And so what makes gold hydrogen as kind of special and differentiates us from some of the others is that we can do it at basically the same or similar carbon intensity as green hydrogen, but also do it for a lot less expensive as green hydrogen, because that seems to be one of the big concerns with the cost of producing green hydrogen. So the way this works is because we're using existing infrastructure already, so we don't have those large capex costs to basically drill new wells. We can go into wells that are already there, assuming that the integrity is in place. So we have minimal surface level equipment. The reservoir acts as the bioreactor itself, so we don't need that. And then really all we need to do is the processing on the top side, and being able to figure out what to do with the CO2, getting that back in the reservoir, and storing it there, and then processing the hydrogen further. The other great thing about this being that it gives a second life to these depleted oil reservoirs. It also utilizes existing oil and gas talent and know-how. Essentially, you're going from being, producing oil, you're going to use the same kind of operations. You're just now turning it into producing hydrogen. So you save all of those jobs. You use all that, experience and knowledge that's out there, and you don't have to. And then, like I said, you don't have the large capex of building new things. So all this together allows us to estimate, based on our techno-economic assessment, that we could produce our gold hydrogen at $1 per kilogram or less, which is what the Department of Energy put out as their hydrogen shot goal that we're really going after. And so, kind of, as Kent mentioned, right, that our technology is going to work really well in some idle wells and not so much in others. So where does it make sense? And we believe not only is the hydrogen sandbox really large with enough room for us to play in, we also believe that the idle wells, as Kemp mentioned, that sandbox is also very large. And so there's lots of room to play with others as well. And I won't get into a lot of the technical details here. I'd be happy to connect with people later to go into more details if you're interested. But really, it comes down to a balance between kind of biology and economics. So anytime you're looking at microbiology in a reservoir, you've got to be cognizant of temperatures, in certain parts of the water chemistry, salinity, et cetera. You don't want to be too high. So that's just going to be able to sustain microbial life within our bioreactor in the reservoir. And then, as Kemp mentioned also, right, economics is going to be important of, what infrastructure is there, what's the integrity. Obviously, I mentioned we're looking at end of life assets. Right now, it wouldn't make sense to turn an active producing well into a hydrogen producing well. Who knows in the future what that could be. And then we're also looking at, water flood applications to make this a viable commercial technology. So I've said a lot of words, and I'm sure it all sounds great on paper, but now you're probably like, okay, so what have y'all actually done? So I've got a couple minutes left. I will breeze through a couple of years of work in 2 slides, as we usually do, right? So we really kicked off with lab design and optimization late last year, and had a kind of a target hydrogen production rate that we wanted to be able to have the microbes hit before we looked at going out into the field. And we were able to hit those numbers really quickly. So while we are still doing a lot of R&D, high pressure, high temperature testing, as many of you know, right, the reservoir is a giant black box. So we've got a lot of biogeochemical modeling that we're looking at to really understand how our technology will move throughout the reservoir, and how feasible it would be. So those are all still ongoing, but because we had such great success in the lab, we moved into a single well pilot late this summer to really test the technology. So we partnered with a Permian Basin company back in July. We were able to look at putting our microbes and nutrient package down a single well, injected them into a single well. We shut in the well for a few days, and then after opening the well up, we were able to measure hydrogen. at levels that were way over significant quantities above the baseline that we had measured previously at that well. So this was extremely exciting. This was kind of the first test of, can we put our technology in the ground and get hydrogen out? So it was really a binary yes or no, pass fail type situation. So with the success of that, we had been working also in the background of setting up a subsidiary company under Cemvita called Gold H2 LLC. So we formed that and raised funds into that company to continue driving this technology towards commercialization. And using some of those funds, we have been really, full steam ahead on preparations for our next kind of water flood pilots in the field to be able to really test the technology at a more commercial scale early next year. We do see the value of this beyond just domestically as well. So we have been partnering with several international companies to kind of qualify the technology too. So we're continuing that as well. And as I'm sure I can already see that the probably thousands of questions you have on the different challenges of microbes in the reservoir. So it's definitely something we are continuing to work on and optimize in the lab, but we didn't want to lose, steam and momentum on getting it and working on testing it in the field at the same time. So we still have a lot of work to do, but we are very excited and really do see gold hydrogen as being a key player in the energy transition and bringing the oil and gas industry into it through gold hydrogen as well. And I think that's all I've got.
Thank you, Alicia. That was fascinating. There were a couple questions thrown into the chat, and again, we'll save kind of questions till the very end, but if you want to hop on and type an answer, that's okay as well. I will move on to our next panelist, Matt Hogg of GeoGen. Matt is a professional engineer with over a decade of experience in the energy industry. Matt committed to providing new solutions for the energy industry and building teams to bridge the gap between old energy and new. He's worked on a variety of projects focused on technology adoption within the oil and gas industry in various engineering roles, kind of including facility, reservoir, and production. And he is my third example today. I think you're starting to see the point of an oil and gas professional helping drive this energy transition. So I think I'll stop there. I'll stop making a point there. A little quick summary of GeoGen is that while oil and gas wells were not drilled to be geothermal wells, they can be repurposed to harvest heat. And GeoGen developed a new thermodynamic process to underpin a well design that will lower the cost to convert a well to geothermal that's more in line with the output potential of a typical oil and gas well. So horizontal wells offer the best geothermal potential, but any well could become a geothermal well with GeoGen's technology. So essentially, we have an infrastructure via oil and gas wells, conduits from subsurface heat sources to surface, and leveraging that as an asset could save dollars and provide carbon-friendly solutions. So Matt, I'll let you take it from there, and I'll start your timer.
Great, thanks. Thank you very much, Stacy. I'm excited to be here today, and so inspired to see all these cool kind of solutions to what I thought was an amazingly incredible opportunity, which is all these old oil wells and the need to finally clean them up. So at GeoGen, these end-of-life oil wells, we see them as renewable energy assets, specifically geothermal assets. And in order to do this, we needed to come up with a new model for geothermal based on kilowatts rather than megawatts. So to make it profitable, this needed a technical breakthrough, and we developed the GeoGen cycle, which is a new thermodynamic process. At a high level, traditional geothermal is steam on surface making electricity. We are using the liquid flowing down, much like a hydro dam, to generate power, 8,000 feet below surface. And then the geothermal heat vaporizes that fluid through the horizontal section, causing it to return to surface where it can condense, and then the cycle repeats. The impact there is that we're going to be deferring well liabilities, arguably indefinitely, and produce emissions-free electricity right alongside. And we're targeting 6 cents per kilowatt hour for our LCOE over the longer term. Now, not sure if any of you were in Huntington Beach in the 1920s, but maybe some of you haven't seen this photo before. These wells are obviously all over in our communities. Now, most of these wells have been cleaned up, but I think the similar thing can be said all across Midwestern United States and Canada. as to where these wells are, and they're really in our communities. Over 2 million have been drilled, costing trillions of dollars, and now we're going to spend billions cleaning them up. That's we're hoping that there's another option. If you have, say, $150,000 liability, and this is up in Canada, the cost to all the way from plug, abandon, remediate for a horizontal well, that well can produce $150,000 annually in electricity revenue, right? And that electricity revenue is renewable, base load, dispatchable power. Now, within the segregations of maybe quality of the kilowatt, we're not separating within renewables yet, but this is the kind of power that gets you to 100%. This is the kind of power you can run a pump jack on all day, every day. And it's really, the kind that's going to be able to take it, to the end of the road. It's competing with, battery storage and that sort of thing. When we look at geothermal as a renewable energy source, which it's been for hundreds of years, it's never scaled, and it's never been investable because it's really hard to predict. It's even harder to find than oil and gas. I think a good geothermal resource, and just because there's a way to do it in the Salton Sea or in Iceland doesn't make that the best way to do it in every well. So with us, geothermal becomes predictable and investable. And our customers, which are oil and gas companies, they're going to be eliminating their Scope 1 emissions and arguably a huge chunk of their wellbore liabilities at the same time. Now, what are we doing? So as I mentioned, it's the liquid flowing down to spin a turbine that is kind of the source of the electricity. There's a huge swath of wells that can generate between 100 and 150 kilowatts of electricity, offsetting about 500 tons a year. And the first thing we do when we go into a well is kind of like, say you're running a liner for a refrac or something along those lines. And we seal off the well completely. Then we stab in with a tube inside a tube. And we're able to create a flow channel down and a flow channel up. Inside the well itself, we kind of circulate it over until it gets to a clean refrigerant. And that refrigerant is very similar to ones that you'll have in your refrigerator at home or in your car. These are just industrial refrigerants. And the reason we're really targeting the horizontals, as you can see from the graphic there, is that 40% of the well is in the hottest part of the well. And what this really does is it adds a certain longevity to the geothermal resource. And a single well is enough for it's about 75 homes. These are average homes. But we want an old well bore on your property kind of be seen as you and your closest 74 neighbors are now off the grid, and we're hoping that sort of value can get unlocked with what we're doing, and with I think a lot of what everyone else is doing here. So where we are today is the hottest oil and gas wells can be economic sources of geothermal, but we've got some work to do, but we have line of sight on how we're going to get down to 170 F as our economic cutoff for producing a power. In this case, we have tens of thousands of existing wells, and it would be about a third of the wells we're drilling today would eventually become geothermal wells. Now, zooming out a little bit, what does that really mean, and where are we at today? We've got billions of dollars of potential work to do, so to speak, and that's going to be able to offer gigawatts of electricity. There are already so many inactive horizontal wells, and like we were saying before, there's a wave coming here, a bunch of strip wells, but GeoGen has this opportunity to really assign a terminal value to a lot of these wells, and when we look at the amount of hot wells available today, there's no reason to get started. And going after those hot wells first is eventually going to allow us to develop and mature our technology to make all of the other wells viable sources of electricity. So our model and our mandate is really to enable geothermal conversions. We want folks who are well owners to become geothermal well operators. Now we're like an easy button. It's a turnkey service. GeoGen comes on a well site of an active well, and then we leave, and you have a geothermal well that's capable of producing, again, between 100 and 150 kilowatts of electricity per year. And then there's a host of environmental benefits, and I think a lot of new tax benefits associated with these sorts of projects that really help push it over the line for oil and gas operators. And that's really, I think, a huge opportunity for us and everyone on this call, is that these operators produce and consume a lot of energy. That consumption of energy part is an opportunity for them to basically increase their net back per barrel. And our partner in our very first well, which is ongoing right now, and I'll go into a little bit more detail about that here in a sec, has the goal of using this power. They are in the process of electrifying their operations, and they see this as a kind of a great kind of way to dovetail into that initiative. They have 20 end-of-life net wells today, but 500 future end-of-life wells, and they're drilling more every year. By the time we finish this demonstration project, we're going to have demonstrated downhole power generation in a well that's 170F downhole. We'll have evidence as to the commercial and economic sort of drivers around one of these wells, and really have very valuable data around the heat drawdown, which is going to allow us to kind of work towards optimizing our design overall. And one of the reasons we're doing this well up in Canada in Grand Prairie is because as of August this year, there's a new geothermal regulation that was published by the regulator up here, and they have created a mechanism to transfer an oil and gas well into a geothermal well. It's not as easy as transferring well over to, say, an injection well or something like that, but I think it's heading in that direction. So that part is great. You can own heat rights in Alberta now. You can own the rights just like you own mineral rights. So folks are, there's a little bit of de-risking happening on the regulator side. And then at the same time in Alberta, the government's mandating spending on inactive well remediation. And it's labeled at something like $500 million a year today. And it's a number that's passed down directly to the oil company from the regulator. And I think that's just more evidence to the point made earlier that you can't walk away from your well liabilities like you used to. These companies have been building these wells up for a long time, and now the bills come due. And the alternative of cleaning up a well is no longer, there's no longer a do nothing scenario really for a lot of people. We're hoping that similar sort of regulations will come to pass in various states. We want to do our next pilot in the United States, and we are currently talking to a variety of different operators who have some of those really hot wells. These are in areas like the Haynesville and the like. So we were talking to a couple of operators right now about doing our next project down there, and just really excited to go as quickly as we can, because a lot of this technology has already been developed, and we just need to kind of repackage it and really focus on that operational excellence to be able to deliver it at a price point where the resource makes sense. You'll see our team here. If I'm one of these old wells. I was in oil and gas for 12 years. I am a chemical engineer by training. It means I chase energy around, and whether it's fossil fuel or any other type or heat, to a certain extent, it's all the same. My entire team is made up of oil and gas folks, and these guys have the skill sets that you kind of need to do exactly what we're hoping to do. And all that being said, there's a huge foundation of technology here from running downhole pumps and that is really going to help us go faster. We've got some incredible partners, including Seafer Technologies, which, if you're not familiar, they're up in Edmonton, Alberta, and they were fundamental in development of SAGD. They understand thermal wellbores like no one on the earth. All the major companies kind of go to them for call it third-party analysis. They are helping us. They've third-party verified our process, and we've got Spartan on board. We've got some grant support from various agencies up here in Canada, and we're expecting to see a lot more of that go forward. We currently do have an open funding round, and in part to support execution of this project or later phases of it, and really to kind of continue on our path and accelerate as quickly as we can. So I know that I can probably keep going, but maybe help catch up a little bit, or perhaps take a couple questions, as most of what I had prepared. But happy to answer a couple questions if there's time.
Okay, thank you, Matt. Appreciate that. We did have a couple questions, but I actually think your co-founder hopped on the chat and answered a few of those. Yep, he got the last one there too. And you got a compliment from Kemp about having a really cool logo. So well done there.
Thank you. We copied it out of a children's book.
Any other questions we'll save to the end, and I will move on to Megan Spicer. Megan is with OneNexus, and this is a little bit of a different concept here. So first, to introduce Megan, she has over 15 years of experience in the energy industry, insurance, energy, communication, and industries. She has held various in-house marketing and communications roles, as well as consultant and advisory roles. Her current focus is on corporate social responsibility and ESG within the energy industry specifically. So energy industry folks, not just engineers and geoscientists, also translate to energy transition things. So Megan is a graduate of the University of Akron with a bachelor's degree in visual communications, something that us engineers need help with desperately. And she's wrapping up an MBA at the University of Houston. So congratulations on that.
Thank you.
A quick summary of OneNexus before you jump in. OneNexus, if you haven't heard about them, they've been around for what, a couple of years now maybe, but they're a financial risk and decommissioning management company, and they focus on solutions relating to liabilities in the oil and gas energy industry, specifically asset retirement. So OneNexus's mission is to prevent orphan wells by ensuring that ARO liabilities are funded far into the future and assets are properly decommissioned. And personally, I think that this is sort of a culture shift for oil and gas that's much needed. So this concept of reassociating end of well life decisions with the full cycle economic decisions that get made by oil and gas executives and operators daily is critical in managing that pipeline that we've all kind of touched on. So thank you, Megan, for being here. Look forward to hearing what you have to say, and I will let you take it from here.
Thank you, Stacey. So I'm going to share my screen here. So give me a second, and I'll share and go into presentation mode. Here we go. Everyone see my screen okay? Okay.
Yep.
All right. I'm sharing the right screen, right?
Yes.
All right. Okay. So thank you again, Stacey, and thank you to Carbon Expo for inviting us to talk about OneNexus. We're really excited. We're happy to see there's so many people in the space to talk about this. Just like Stacey mentioned, we are seeing a shift. We really wanted to be part of this kind of change. So we really appreciate the opportunity to talk about this. So again, Stacey covered a lot of this, but we were founded in 2021 by industry professionals wanting to make a difference. We really, we really just saw a lot of opportunity here, and we started looking at this problem a little bit different. So we do have some engineers, but we also, and there's a lot of engineers in the room today, but we also, there's several of us that are more on the finance or kind of the business side, and the way we looked at it was a little bit different. So for some background, there's a lot of us have talked about the problem. There's a big problem, and Kemp mentioned the ARO. So there are currently nearly $500 billion of underfunded asset retirement obligations in the industry in just North America, right? And this maybe even just US. That number is growing every year. There's 20,000 new wells drilled on average. And so I want to stop for a second and just kind of explain what is an ARO. So an ARO is the asset retirement obligation. It exists the minute a well is drilled. So this is a financial obligation to fulfill the decommissioning, So to safely plug the well bore, remove all surface equipment, there's a lot of people here that understand all of this. But also, like in many cases, there are states that require that you return the land to its natural state and leave no trace. So the reality is these have been underfunded, and they're just not getting funded. So so we need to change as an industry. We need to change that thought and that life cycle. So we came together to create OneNexus to address that change. We wanted to make this, an industry approach. We wanted to understand, all of the stakeholders that are involved. So we wanted to partner with oil and gas operators, landowners, to really shift the change in how people are thinking about planning and funding the way they decommission wells and the way they're planning for that. So that's where we came up with OneNexus Assurance. So it's a financial offering that really ensures that there's going to be funds available to decommission the wells. We also have an operating arm, which we call the first decommissioning operator, and I'll explain a little bit more of what we mean there in a minute. But we've recently just got some good backing from Munich Re, which is a big reinsurance, their global reinsurance company. So that's huge news. And we were just able to announce that just a few weeks ago. So that's pretty exciting about where we are right now. We're gonna stay on the ARO topic for just a little bit longer because it's really critical to the problem. And I think Dwayne covers this a little bit more in detail, but so what this slide really illustrates is that, when production and revenue is highest at the beginning of the well, there's many people, this is not new for anyone that understands economics of a well, but as the years go on, that arrow doesn't really do anything. That just sits there until there's really nothing left. So nobody is planning for this arrow at the end. So as everybody knows, the industry is cyclical, and at the end, there's no money left. So people walk away, and that's how we get these orphan wells, and that's how we're in this big problem in the first place. So what we really wanted to do was take a proactive approach to asset retirement. So with OneNexus Assurance, we're providing a financial assurance for a product in the future for decommissioning. So we are funding future liabilities, and it was important for us to really structure our company in a secure way. So we wanted to make sure, so this is where we say we're insurance-like. For multiple reasons, we use insurance as kind of an analogy here, but one, its insurance purpose is to kind of guard against things in the future. So that's really why we wanted to make sure that it's an established and trusted mechanism to do something already. And so we're just applying it to something that hasn't been applied to before. So we structured, and so we are structured as a licensed and regulated insurance company. And we partnered with Munich Re, which is a AA rated reinsurance company, to provide additional backstop capital, so that we can really offer this product to stand on its own. So yes, we're a new company, but we have a huge, we had to make sure that this is going to be secure and safe, and that companies can really count on us long into the future. So I mentioned decommissioning operator before. Everybody knows here that there's operators, and that's really who can manage the well. And so what we did was, when we kind of set out, we needed that operating arm. So we call ourselves a decommissioning operator for the sole purpose of like decommissioning the well. So we're not gonna produce it. We're not gonna do anything else. We're only going to decommission it. So that's there. So when is it best to add OneNexus Assurance? So, and this is, a financial assurance product for future decommissioning. So this is, the operators will purchase this product. We have 4 cases that we really think are the best times to buy or add OneNexus. So case 1 is really when responsible operators are taking action now. So they're demonstrating this commitment to the full life cycle, sustainable planning. And then, by the way, it costs less when you start, saving for your decommissioning at the beginning. It's less than 1% of your drilling completion costs. So it's a minuscule drop in the bucket for these big development programs. So that's kind of the first case scenario. So case 2 is really during transactions like acquisitions and divestitures. There's coverage for both parties, but really the seller is going to have a high risk. And this is something a lot of people really don't understand, that the state does have the option to go back to the original operator to have them close the well if the buyer of the asset maybe does not fulfill the obligation. So if the buyer 20 years goes down, the buyer goes away, the original operator or the seller, and they are liable. So there are some mechanisms that are in place, but there's really not been a really good, but because there's no financial incentive at the end for the current financial assurances. So I'll get into that in a second. So for case 3, so this is really when you have a portfolio of aging assets. So if you're not really sure what to do, but that these liabilities are coming, I like to call this the best time was 20 years ago to save for your asset decommissioning. The next best time is now, kind of analogy. So that's really kind of the case 3 part. And then case 4 is, I touched on with case 2, but it's really whenever there's financial assurance that is needed for a third party. We've really went out and created a product that was superior to the traditional methods. So letters of credit, the surety bonds, anything like that. We will also provide, we provide that same assurance, but the benefits are to the operator, not just to the person who needs to be that third party. So with it's being weird on me. Hold on. There we go. So we have, I'm going to touch on kind of the two areas that we've kind of the options that we have with OneNexus Assurance. So the main difference for these is the defined benefit is financial assurance, and it's a guaranteed amount. And we work with the operators to decide what they need. So if they have an amount in mind, that's really the guaranteed. So they decide, and that's what we work towards. The second one is full risk transfer. And this is really where our decommissioning operator comes into play as well, where it's both financial assurance and the performance assurance. So when they are done operating the well, they want to kind of wash their hands of it. We're done operating, there's no economic value left in this well. Here, guys, come and take it. So we'll come take it and do all the work. So those are kind of the 2 main options there. So I mentioned how we're superior financial assurance. These are, I don't want to get too far in the weeds because I want to keep to the time, but we do have, you'll see the main point of the slide is you'll see that, there's a lot of checks in green on the left under our product, and the traditional methods of assurance really that have gotten us into some of this mess in the first place. They just don't do all the things that need to happen. So really that's kind of the point of this slide, is that, it's really a superior product, superior financial assurance product. So there are a lot of ways that OneNexus Assurance fits into risk mitigation strategies for companies. I will plug our website because a lot of this can be on our website. So it's onenexus.com. But prudent like management and risk management and prudent governance is really important. I'm going to talk about that in just a second with ESG, but you can kind of see there's a lot of different ways that we fall under risk mitigation here. So ESG commitment, financial, the main thing is we have to do things different, right? So the industry has to change the way they think about closing their wells or saving for closing their wells. Their ARO needs to be met. They need to make sure that they're being prudent and taking that governance step. Investors want to see that more and more. And then the other, benefits under environmental, obviously, fugitive emissions and, potential water and soil contamination, all of the things that come with leaving idle wells or stranded assets, the social impacts that come with leaving these in communities. So all of these things really fall under this planning element. So that's, they really need to make sure that they're taking this step in planning and taking action today to something that they can do in the future, that they have to do in the future. Again, commitment to sustainability. This kind of comes back to that full life cycle of a well, and really planning that sustainable development cycle. If you're not planning for decommissioning, it's not a sustainable business. It's not, you're not doing the right things. You're not being, a good steward. And the companies have those responsibilities. There are environmental responsibilities. You need to be thinking about how to clean up these wells at the end so that you can go back to different, close them up. Maybe there's a different land use. Those are all things. So planning is really critical, and guaranteeing that the funds are there is really that step. So because the burden really should not be placed on taxpayers. So last, I mentioned Munich Re, and we have a lot of really big names. And it was really important to our mission to do it this way, because our product has to stand on our own. We have to be, we have to make sure that we're here to promise these future obligations and promise that this happens. So all of these companies have been really supportive and partnering with us and sharing our vision that there's something that needs to be done and helping us leave things in a better place than we found them. So that's it.
Thank you. I know we had quite a stream of activity on the chat as you were talking, Megan. So I'll push that again towards the questions at the end. But it's a really kind of interesting product, and again, different than some of the technological things that the other folks talked about. So very cool. Thank you for putting that together for us.
No problem.
Next person up is Dwayne Purvis. He's been pretty active in the chat, and I'm assuming most everyone knows Dwayne. He was instrumental in putting this event together. So as a quick introduction, for those of you that don't know him, Dwayne is a reservoir engineering consultant, writer, speaker, mentor, and trainer. Relies on 25 years of experience across hundreds of studies and multiple leadership roles. Dwayne deconstructs complex engineering and strategic questions to help operators to make better decisions. And I'll say personally, Dwayne's ability to break a complex problem down into a palatable kind of baby steps is much needed amongst all the rhetoric that we see going back and forth for energy transition. So a good friend of mine, Lindsay Jaffe, once advised me to focus on the one thing that in doing so makes everything else easier. And I'll say that Dwayne is exceptional at that. And I'm very fortunate to benefit from his insight every now and again. So his engineering experience ranges over 24 basins in the US and abroad, understands a wide variety of geologic and reservoir dynamics. He's worked for all kinds of clients, ranging across, the spectrum of multi-owners to major oil companies and state and federal and international government agencies, tons and tons of projects, tons and tons of experience. He spends a lot of his time now writing and speaking and teaching nationally on engineering methods, processes, and thankfully ethics. So welcome, Dwayne. Thank you for helping us put this together. Thank you for being here. And I will let you take it from here.
Hey, thanks so much for that introduction, Stacy. Very generous of you. I love what Megan was saying. about we need to plan. And the old adage goes that a failure to plan is a plan to fail. And that is the case with the AROs. Over the last years, cash flow has gotten really good on some really crappy wells just because prices quintupled. But when they came back down again, we found ourselves surprisingly close to the end of life. But we continued to defer our ARO obligations, and we continued to use our conventional present value economic yardsticks. So what I want to show you today is nothing more than a measurement. This is a way that you can begin to plan. The problem is that present value yardsticks distort the appearance of the ARO obligations, these hundreds of billions of dollars of obligations that the other speakers have been talking about. It distorts the appearance of them and makes it look like they're much smaller and much easier to deal with than they are in fact. Let me show you how the reality of today's situation compares to the theory of analysis. So 27 years ago, when I started my engineering career, I was told AROs don't matter. They're too far out in the future. We'll probably sell the property by then. Probably the costs are offset by salvage, and present value wipes it out. And at the time, that was true. This graph shows what it looks like with the increasing discount rate and decreasing value at that discount rate. So if I add AROs in at the end of a normal cash flow, it changes the undiscounted cash flow some, but by the time we get up to a discount rate of normal value, it's the change is incremental. The change is minute. But what we've done, in fact, is to accumulate our plugging costs in particular. We've let those wells sit there. So now we have a large ARO and we have a smaller cash flow. So like Megan was saying, at the beginning of life, the plugging costs are trivial by comparison to the capital costs, but our cash flows naturally pinch out with time. And by comparison to the end of life cash flow, the ARO for not just that one well, but the other 4 or 5 or 10 wells on the lease that haven't been plugged yet, the ARO is very significant. So when I add this ARO into a cash flow that's late in life, my whole present value curve shifts. As I approach the point in time when the undiscounted value becomes negative, when the total ARO is equal to the total free cash flow, then my present value trend warps upward. And it's actually possible for us to see a present value at 10% that's greater than undiscounted present value, which of course is the complete opposite of what economic theory tells us. We could pay for a property, pay a PV10 for a property when in fact all of the future AROs are greater than all of the future net revenues, which is scary and mind-blowing. Let's look at it a different way. Economic theory says, as I approach the end of economic life, that is, as I move from left to right along this graph, my present value should fall, should decrease. More of the revenues have been realized, less in the future. But at all times, the present value, 20% of the discounting to account for risk is less than the 10%, and that's less than undiscounted. But when I put a large ARO at the end of life, then my AROs are discounted more than my revenues. So all my revenues come first. They are risky. They get one level of discounting. My AROs are guaranteed to be owed, but they come later in life and discounting makes them more reduced than all of the revenues. So when I change my graph here, I add in an ARO, all of a sudden you can see my lines cross. And in this example, and this is just a schematic example, but with the right kinds of proportions, my undiscounted value becomes less than my net present value 12 years before my end of economic life. And at some point in time, my present values, PV20 can be greater than PV10. And both of those can be positive even when the total cash flow in and out of the project in the future is negative. So for those of you making loans or investments or operating a property, present value can make it look like you have an asset when in fact you have a liability. Let's look at it one more way. This is a graph to show, a table to show the ratio of the present value of the future net revenues compared to the present value of AROs as I approach the end of economic life. And this kind of looks like you'd expect. As I move down through the table, closer to economic limit, the present value eventually inverts in the last couple of years. But present value, with the discounting, distorts the picture. And if I do it on a cash basis, then a single well to pay for itself can easily take the last 3 to 5 or more years of all of the cash flow to pay for the plugging costs. Or said differently, if you wait to pay it until after it's dead, you're going to have to come out of pocket equal to all of the money you've received for the last 5 years. But that's true if one well is paying for its own decommissioning, but we have accumulated retirement obligations. So right now, about 2/3, closer to about 60% of all the wells in the US are sitting idle, and the remaining 40% are producing. So each well has to pay for the plugging of other wells in addition. So if I look at an asset, a single field that has 10 or 15 or 150 wells in it, if half my wells sit idle in this column, 50% sit idle, then in this schematic, it takes 10 years of cash flow to have enough money to pay for plugging. So as we move through life, as a field moves through its life, and more wells are idled and production declines, what happens is that a property moves this direction through the table. Later in life, less remaining money and a larger proportion, larger ratio of a liability to asset. And what I've seen, in fact, in a number of cases in my practice, is that fields can take 10, 15, even 20 years of the final cash flow to be able to pay for the plugging. So if I have 60 or 70% of the wells in the field right now sitting idle, then those costs are due right now. But if I wait to the end, I won't have enough money. I'll have to come back out of pocket. So the idea is just, like I said, to measure it. The cash flows can be positive, present values can be positive, and it can still be upside down. So here's the way to deal with it, the way to measure it. And then you can figure out the strategy by talking to Megan or Kemp or Matt or Alicia. The idea is called holdback, and this is payout in reverse. So payout is the amount of time it takes for the revenues to equal the capital that has been expended. Holdback is the opposite. The amount of time it takes for the cash flows to equal the capital that will be expended. So if I'm sitting in this point in life, I have some period of time that's distributable cash flow in theory, never mind setting aside the issue of risk, and then I have holdback, in which no profits can come home. They all need to go to the current liabilities. There are several other economic yardsticks that can incorporate the ideas of risk, like coverage, the ratio of net revenues to costs. Discounting can recognize the inherent risk of the cash flows, which are disproportionately larger than the cost of AROs. But all those just extend the fundamental question, the fundamental recognition that the liabilities are actually a whole lot closer than they appear to be. So we need to calculate the economic yardsticks. You need to talk with your non-ops so they don't stiff you, and make your own plans so that you don't stiff the taxpayers. And then, yeah, if all else fails, man, today might be a great time, a better time to plug than other times. But it starts with just a simple economic calculation so you can make better plans. Thanks, guys. Stacy, how'd I do on time?
Very good.
All right.
You were great. Thank you for that. We have we have about 30 minutes left in the session here for questions. And I know that in the chat, there were several that were directed to some of our panelists. So I'll let you guys respond directly to those. And I'll throw out a few of the other questions that we had in the queue, maybe some for all panelists, and there may be some that are more specific. So I'm going to start with Kemp. I think our first panelist explained this a little in his presentation, but for the rest of you, maybe Megan, excluding you, to what percentage of the total non-producing well population do you believe your solution to apply to, or maybe asked a different way, out of that very large population, maybe if on exactly which types of wells or which regions work best for your technology? And Alicia, Matt, Megan, if you have thoughts here, I'd love to hear them. And Kemp already kind of answered.
Yeah, we've narrowed down the number to what we think is 30%, and that 9 suitability criteria, most of which I covered, or all of which I covered in the slides. But you know, we want that number to go up. So we've tried to make some conservative estimates, particularly around casing inclination and dogleg severity, so that we can put to use curvier wells. Yeah, right now the number sort of hangs at 30%.
Okay, Alicia or Matt, do you guys have thoughts on this?
Well, I think with a lot of them, I wouldn't speak for anyone else. It's really a function of economics. Like the resource is limited to what it is, and so it's like how cheap can you implement your solution. So I think for us, we're like 5% of existing wells, but arguably up to 2/3 of new wells. So the types that are being drilled today. So we love that idea of taking the life cycle in mind, walking into, you know, spudding the well, and that every well that you're drilling is going to eventually be a geothermal well. It's just going to produce a well for the first 30 years. But in terms of the existing wells, it's the hottest for us. And then, you know, as we get our costs down, more and more become options, and that kind of increases exponentially.
Yeah, Alicia?
Yeah, I would say the big thing for gold hydrogen is we're looking at water flood applications. So that's going to, you know, conventional water flood applications. So that's going to limit us. And then, as I mentioned in the talk, reservoir temperature is a big one. So we're really looking anywhere between 130 to 180 Fahrenheit, with like kind of 150 being the sweet spot. Now, as our technology continues to, you know, evolve, and, you know, as microorganisms evolve, we might be able to expand into others as well. But right now, that's kind of where we're looking.
And it would be very interesting from my perspective to see sort of the Venn diagram of those well sets from Matt, Kemp, and Alicia, and see if there are any overlapping moments there, because, you know, it's a very population, and you guys have some specific needs there. So next question is, after Dwayne's presentation, does that sort of hold back and understanding the liability associated with these wells? Are you guys, as potentially new operators for new energy transition things, are you guys incorporating that type of asset retirement obligation into the models you're running and into your own, the way you're thinking about your businesses and your technologies? Or are you maybe not quite far enough down the road to be thinking that long term?
Speak for us and say, like, absolutely 100%. When we walk into an oil and gas room, we say, like, look, here's what this is going to cost you. Here's what we can do. And most often we get something like, well, what's the economic return? How can we be sure that it's going to meet the same requirements of our other capital? And I tell them, this isn't your other capital. This is non-discretionary capital. And I hate to be the bearer of bad news, but you don't really have the luxury of picking your normal returns for this money.
Okay.
Yeah,
How
I
does
would say
that go over? Yeah.
Honestly, this is the response I get the most, which is that they say things like, oh, well, there's a lot of other purposes for the wells out there, and we're looking into them. And I'm like, well, you're not doing them very fast. I mean, I don't say that, but I just kind of like, if you need a volume solution, and sorry if I'm tooting my own horn here, but like, I am a volume solution, right? You've got thousands and thousands of wells. And even if you do like an all of the above approach, you're going to need a solution for thousands and thousands of wells. So I don't know if this is too cruel, but oftentimes it kind of rings hollow. They're like threatening us with, oh, we got lots of options. Okay, well, show them to me.
Matt,
Yeah,
or
we hear similar kind of sentiment. People really, now some people really understand it, right? There's a lot of operators that are really starting to understand that this is a big problem, but there's also some that are not quite convinced that they can't spend this money still, right? They think that they can spend it somewhere else and make returns somewhere else, and they haven't figured out quite, they think it's just gonna keep pushing it down the line. So I've seen similar sentiment.
Alicia or Matt, do you guys want to add anything there?
Only that I've kind of heard a similar lack of urgency from folks I spoke with. Yeah, we know we have that problem. Who cares? I make money drilling for oil wells, right? I think as regulators and ESG becomes a higher priority, that's maybe only a conversation that's going to be had, outside of the public kind of spotlight. But yeah, I don't know if they've fully taken it seriously or as seriously as they should be.
And do you see difference in public company sentiment between public company and private companies?
Yeah, but oddly, it's the other way than you'd expect. To a certain
I think
extent,
in my interactions, I was just gonna say, in my interactions, it's the big companies who have more complex idle well management strategies. And so they feel comfortable managing the idle wells for longer because they've got the time and resources to have a whole regulatory department tear through what are usually difficult to understand regulatory guidance. Whereas the smaller ones are kind of like, hey, if you could give me a way to get out of this right now, I would totally do it. And that's sort of our goal for the smaller oil and gas companies, is that they seem to be mostly just looking to wash their hands and walk away. And we would love to be that kind of solution for them.
Got it. Okay. All right. And my next question is around the maturity of the different technologies. Most of you kind of answered that in your presentation, but Megan, I wanted to hear from you specifically. Have you guys, do you guys have partnerships in existence with oil and gas operators? And if so, can you tell us a little bit about how that's going or what your pipeline looks like?
We're not quite, we're really close. We're ready to do that. So if you know anyone that's ready to take that step, we do have several things in the pipeline, and we can't disclose it, who our operators are, and the ones that we're talking to. But I will say, just kind of come back to the public versus private. There was a question in the chat about arrows and how they're thinking of it. There's always going to be your good players and your responsible players, and then the ones that are not as responsible or not really as prudent financially. Public companies, I think, are going to get more of the ESG pressure. So if they're asking for public dollars and they're going to it's going to become a bigger issue. So there's going to be more pressure there, but it's not an issue that private operators aren't going to face too, because they're going to be the ones, like a lot of times the smaller ones are kind of left holding the bag at the end anyway. So if they want to think sustainably and they want to continue long term, they're going to also have to plan and manage their decommissioning. So really that's, kicking the can down the road is not a strategy, right? Like you have to save and you have to think about it and you have to plan and put monies away so that you can have that to do what you're supposed to do.
Yeah. What was the line? What was the line?
Kicking the can down the road is not a strategy.
Hope is not a strategy.
Hope is not a strategy.
Right.
The best time to do this was 20 years ago. The next best time is now.
That's right. That's right.
Well, so speaking of kicking the can down the road, for those of you from the oil and gas industry, one of the more shameful things I think that the industry has kind of participated in over the last 50, 70 years, I'll say, is that kicking the can down the road. And one of the ways that we've done that is by claiming future utility of some of these wellbores, be it for secondary or tertiary recovery. And so my question to you, maybe Dwayne, I'll start with you, is how often, once a well has gone offline and is no longer, productive, how often do you see those wells being brought back onto production for a second go?
So
then of course,
I think
else.
Yeah, in theory, a well can have option value. Something could possibly come along in the future. In reality, it's a unicorn. If a well goes down and you can bring it back in 6 months, that does happen. But for wells that sit idle more than 12 months, I'd say it's very rare for someone to, after making a decision to let it sit long term, to find a use for the well, or have prices come back enough that you can restart the well. I've heard it happen, but the people I've talked to have experience like mine. They've seen it happen a couple of times over decades of experience.
Yeah. And then what would you guess is the average time frame between when a well goes off production and when either a new technology like this is put into place or the well is plugged? What would your guess be at that time frame?
I have the wells that are right now sitting around but waiting to be plugged are sometimes 30 and 40 years old. We've had wells sitting idle. A large portion of wells have been sitting idle for more than 20 years. As far as I can tell, there's no incentive to get it done, and how long they're going to sit there just depends on how long they can get an H-1B extension.
Yeah. And so one of the questions that just came up in the chat is how difficult might it be for those of you that are installing new technology in a well? How difficult might it be to remove that same technology in the case of a unicorn where oil and gas production? Is that a possibility at all? Maybe Matt and Kemp specifically?
For us, it just comes down to how much are you willing to pay to drill out the cement plug you put in the well to isolate the reservoir in the first place. Pulling our system out, not that expensive. That's just a workover rig. It just comes down to the cost of getting rid of that plug at the bottom of the well.
Okay.
Yeah, similar with us, but if it's just the plug in the well, and the well is a good candidate, it's probably going to make sense to drill out that plug. We've definitely seen a couple wells that look like they could be good options.
Okay, and Alicia, do you have anything down so far on this that we've talked about?
Yeah, I would just say, the microbes are going to need food. So as soon as you stop feeding them, eventually they'll go away. So it wouldn't be too difficult to do that.
Okay. And so then for those of you installing new technology in these well bores, those wells, just for brevity here, those wells will still eventually need to be plugged, if I understand correctly. What's the time frame that your technology is expected to work before that new ARO comes into play? Kemp, how about you?
Sorry, that I think my internet's not doing great. Could you, what was the question one more time? Or maybe move on to somebody else and I'll pick it up in context.
The
I
pilot
could go
gas
ahead if you
station?
like.
Yeah, the
no, so
question
just,
is, how long can your technology?
Sorry, we all have shoddy internet. I bet we're similar to Kemp. There isn't really a point in time where it's the resource goes away or the well disappears. It's probably a function of casing integrity.
Yeah. Okay.
Yeah, I got it now. We typically answer 30 years, mostly because it would scare people if we said forever. So we just say
Yeah.
30 years.
Yeah, ours is going to depend on the residual
Okay.
oil in place and how much food is there for the microbes. But in our assumptions and what we've put into our techno-economic assessment, we're assuming about 10 years or so, but ultimately depends on the oil that's left.
Okay. Okay, and so I'm going to move topics a little bit here, kind of back to my original point when we started, and the kind of brilliance of leveraging oil and gas expertise into this energy transition. For those of you that came from a more traditional oil and gas extraction kind of background, what was that moment in time like for you, where you decided to kind of transition into this new role, or where you decided to kind of take the leap of faith and move more towards this new, whether it's a startup or an existing company? What did that look like for you, Megan?
So I got interested in sustainability and like ESG probably, I want to say like late 2017, 2018. And I was just kind of started learning as much as I could. And then, I was working a couple different places and just tried to continue to learn just like on my own. Then when I decided to do grad school, I was like, UH doesn't really have a focus, but I knew that there was enough, like I had energy background. There's strong energy component at UH. They've got a strong, there was enough there that I could really kind of walk down that line. Then when the team OneNexus together, we'd all kind of worked together in the past, not all of us, but a lot of us have. And when they called us up and they're like, hey, so we're thinking about doing this and something with orphan wells, we're trying to figure out like how this will work. And then we really kind of figured out it was the arrow. And that's when we were like, this is what we have to do. And we thought somebody had figured it out at some point, right? Like, so we kept looking, we looked and we're like, nope, all right, we're doing this. We're going into insurance. And so I mean, that was really, and now we're, none of us like, we're not looking back. We're all, full steam ahead and really, really we all believed in the mission. There was kind of a moment in time where we're like, okay, so what if it's, we get a well and we're like, nope, we're going to close it, or that's our mission. So nope, that's running through the scenario. So that's, I mean, it's really the last 5 years.
Well, okay, thank you for that, Matt. And I'll start with you. I think, Matt, as a founder, that's a particularly hard decision to make. What was the driver for you?
I think we've had the idea for a little while on the technical side, but it was starting to see oil and gas embracing net zero goals. We had this moment in Alberta, at least, where we had all the major oil and gas companies up on stage talking about how they're going net zero 2050. And then the new regulations coming through in Alberta was, it's just as like at some point you couldn't not start the company is what it felt like.
Yeah. Anyone else have a fun story to tell there about your transition?
Let me speak up to that, Stacey. I've also gone back to school like Megan has. I came to the realization that reservoir engineering services are front end loaded in oil and gas development. The operations engineers, they're going to be the last people employed by the oil and gas industry in North America. But reservoir engineers, well, landmen will be the first people to go, and then exploration geophysicists, but reservoir engineers are on the front end of the losses. There'll be less role for us. But you know, first I was scared, but then I realized how much opportunity there is here as well. If I can get past the fear, there's a lot of opportunity to be seized.
Very cool. Anyone else?
For me, I was I was living in Argentina working for Shell, and I was having this realization while, you know, like I was basically at the forefront of the US trying to export fracking. And it failed in a bunch of other countries, and it was like sort of working in Argentina, but not that well. And I realized, like, if fracking is not going to sweep the world, then really, even if it does, we're going after the kitchen. You know, there's no more drill deeper after this. You know, like you can't drill deeper than where the oil came from and just get more oil. So it started to dawn on me that, like, this is sort of the last major innovation that I see, I could be wrong, where way more oil is going to come out of wells than we thought it was, or way more wells are going to be justifiably drilled. So I just started thinking about, like, well, what is a young industry if this is an old industry? And electricity isn't a new industry, but changing it from what it is to this whole new thing without any interruptions is a massive undertaking. And that sort of drew me because I really liked the sound of that challenge. So that was sort of my journey out of oil and gas.
Okay,
And into
Alicia,
this.
do you want to? I don't want to leave you out.
No worries. Yeah, I would just say real quick. So I did my doctorate at Rice. I became fascinated with synthetic biology, and would have loved to have gone kind of in a biotechnology field that did that, but there really wasn't anything in Houston at the time. So I got into traditional oil and gas. I did oilfield services company R&D, petroleum microbiology research. So it actually was a shift for me to go from doing all kinds of synthetic biology and loving bacteria to then figuring out how to ways to kill bacteria in the oil field. So I spent quite a bit of time doing that, but learned a lot of, oil field experience, which I think then set me up for moving into this role. But, very happy to be kind of back on the good side of using bacteria for good things. So that's kind of my quick come full circle back to the good side of that.
Before I move on to the next kind of topic, which I want to ask a few land questions. Actually, Kemp asked a very good question in the chat that I want to get maybe Dwayne's take on, but anyone else, maybe Megan as well. His question is, what do you do when you go to an operator with this kind of a conversation in mind, and they say to you, well, we'll just go bankrupt, or we'll just walk away from these wells? And then the follow-on question for that is, for those of you that have been through a bankruptcy or have worked with people that have kind of taken that approach, is that still an approach that is happening in the industry, or do you see that shifting as well?
It's a tough question. Mostly people won't say that aloud, that they intend to leave their plugging liabilities to the taxpayer. But there are people who have done it, and some people who seem to intend to do it. The sad fact is that our regulations have created a moral hazard. The companies have the ability merely to go bankrupt and leave it. So I appeal to three issues. First, simple right and wrong. You made the mess, you profited from it, you need to clean it up. And if you walk away and leave millions of dollars of liability to taxpayers, well, this is forced welfare. You are forcing the government to give you millions of dollars worth of welfare. The second issue is to say regulations may change on you. You may not be able to get away with this forever. Things could change on you, and those may or may not persuade people. But what I think we've got to do is establish as a cultural norm that this is not okay. If our industry thinks we're under pressure right now, if we think people hate us right now, imagine billions of dollars going to Texas taxpayers because of widespread surface pollution. And Texas, in a scenario, Texas has to create an income tax to pay for plugging these old wells. If we don't take care of it, we are shooting ourselves in the foot on a public relations. So culturally, we need to address this.
Yeah. And Megan, I imagine you have a lot of conversations with oil and gas operators kind of trying to sell this product, and what's the response you get? And are you sort of still seeing that kind of cultural dynamic?
We are
or is it shifting?
Oh,
let's
sorry.
give Sarah some.
Yeah. So we actually are blown away by like 99% of the operators that we meet with. There's almost we haven't walked into a room and somebody said, "Oh, that's a dumb idea." Like no, nobody really says that. So that gives us a lot of hope. The biggest hesitancy for people that really understand the value of it is, okay, I have to admit I have a problem to a lot of people and I need to manage that. So how are we going to do that? So that's really, and that's where we come in, right? Like we'll come in with strategies and help kind of work with you and say, okay, well, it's better to do it now than 5 years from now and be the last guy on the bus, where you're the one and everybody's going, why haven't you saved for your AROs? What are you going to do? It's going to be, there will be public shaming at some point. So it's, there wasn't a product before that could help. Like now there is. And so we are seeing a lot of interest. A lot of people are getting really close to that. And so we do see the sentiment is changing. So they do understand that they can't operate the same way. So as far as industry goes and that sentiment, I'm hopeful. I have hope that people are going to start making better decisions, especially as energy transition comes in the energy mix. There's going to be more competition and there's going to be other things that like you can't continue to operate the way you have in the past. You have to think about the full picture. So I'm hopeful.
Yeah. Well, I think this panel has given us a lot of reason to be hopeful. My last kind of topic of questions before we jump off is around the land aspect. So the question is, and it came up a couple times in the chat, how do your solutions, maybe Matt, Kemp, Alicia specifically, fit within the terms of existing leases and joint operating agreements and things like that? Are there new legal docs that need to be put in place, or what's your kind of take on that? I'll start with Matt there.
Thanks, Stacy. It is complex and confusing. I think the regulators up here have tried to figure it out, but there are boundaries around electricity and resources, and others. There's three boundaries: electricity, geothermal, and oil and gas, all on the same lease site. It gets a little complex. But overall, the lease site is a lot smaller, and it's a lot less of a surface impact, I think, than any other renewables like that you can think of. So especially solar and batteries. Right. I bet Kemp's solution is similar.
Yeah.
Yeah, I can speak to ours, and that there's some beauty in it, in that a lot of these oil fields, like I said, are electrified, and a lot of them even take it a step further. They have some sort of electricity generation in the fields, which means that they have an interconnection agreement that probably means they can push power back to the grid, which is really beautifully serendipitous, because then we just get to sort of be grandfathered into that. We went through those legal hurdles in California with the operator we work with, and while it was slow, it was certainly not as slow as like the actual interconnection queue. So that was a really great experience.
Good. Alicia, what about you?
Yeah, I would say for our technology, we rely heavily kind of on the microbial enhanced oil recovery, or MEOR kind of what they've been doing in that space. So we kind of follow on a lot of that, but a lot of it too, we're working through as we go and continue to push towards commercialization, kind of what we'll need to look out for.
Great. Well, I am going to try and wrap it up here. I think one of the things that I have loved as being a part of events like this and in doing the work we do with Fellow is that we're early enough in this kind of portion of this emerging little micro economy that everyone is still coming together for events like this and talking very openly about what they're working on. And that's the thing that gives me the greatest hope. That's the thing at Fellow that we try to do above all else. So I want to thank everybody for being here today, being so open and willing to share what they're working on, and please continue to do so for as long as you can. Thanks again to Dwayne and Carbon Expo for putting this together. And I'm going to kind of pass the mic back to them for any closing statements they have. Shamika, I'll pass it along to you.
Awesome. Just do a couple of things here. All right. So again, we want to say thank you to Stacy as well as all of our panelists, and for you, the attendees, for joining us today. We had a very lively chat, so I'm hoping that you all got a lot out of today's session. And with that being said, I would like to extend a special invitation for you to join us for the Carbon Expo, which is going to be held March 3rd of next year. And we're going to discuss some practical steps in the energy transition. So for those that registered for today's session, that's all of you that are present, but even those that couldn't make it here today live, we are having a special discount for you of $99 to join us for the Carbon Expo. And this rate will be available to you until November 18th. So we're gonna go ahead and drop that in the chat for you, but it will also come out in an email along with the recording from the session today. So again, thank you so much. We hope that you have a wonderful weekend, and we hope to see you in March. So check us out on social media so you can get all the updates for everything that's coming out. Have a great weekend.
Thanks so much.
Thank you,
Thanks, everyone.
everyone. Thank you, Dwayne.
Bye, everybody. This was lots of fun.
This was great.
Thanks for having us.